Let's look at this question. A single rail track exists between two stations X and Y. A superfast train S leaves station X for station Y at 8 am, and when it reaches Y, a passenger train P immediately starts from Y and reaches X by 9:30 am. Okay. The speed of the superfast train is double that of another express train E, which in turn is double of the passenger train P. So if speed of passenger train P is 1, of the express train is 2, and of the superfast train is 4. Okay. Uh, on a particular day, due to a technical snag, the superfast train starts at X 30 minutes behind the normal schedule. However, in order to maintain the schedule, both S and P increase their speeds. If S doubles its speed, what should be the ratio of the new speeds of the passenger train and the superfast train such that the passenger train reaches X exactly at the scheduled time on that day? Okay, so lots of information to unpack. This express train looks like a waste of time just to give me a relationship between the speeds. See, once the distance is covered at the speed of passenger train and the same distance is covered at the speed of the passenger train, sorry, speed of passenger train and same distance is covered at the speed of uh, super fast train, can you see this would be this time for passenger train to time for super fast train would be in the ratio 4:1. Also, I know the time taken by both of them together, TP plus TS is equal to 90 minutes. So the passenger train is currently taking 72 minutes and the super fast train is currently taking only 18 minutes. These are the time allocations for them. Now, on one particular day due to a technical snag, 30 minutes are wasted. 30 minutes are wasted. Now, when S doubles its speed, previously it was taking 18 minutes, S will now take 9 minutes. Total time available is still 90 minutes because the passenger train has to reach X exactly as the scheduled time. So the time available for passenger train would be, passenger train has time available of 51 minutes. Previously its speed was 1 according to our estimation, and now its speed would be 72 by 51. Whatever time it was taking previously divided by whatever time is available now, this is the ratio in which it will increase. So the enhanced speed for the passenger train would be 72 by 51. The enhanced speed for the super fast train would be twice of this, or 8. So the ratio here will be 8. Let's cancel stuff out. I get 9 here, I can cancel this, get 3, get 17. 3 by 17 is to 1, or the final ratio will be 3:17, which is option C.